Hi, in this video I'm going to talk about whether a given number is a root or not, also whether a given factor is a factor of a polynomial or not, using the factor and remainder theorem. Okay, so the factor, first of all, remainder theorem says that if you are dividing f of x, a function, by x minus a, then you don't have to do the synthetic division to find out the remainder. So there is even a shorter way to find out the remainder whenever you divide f of x by x minus a. Okay, so that is, you solve this x minus a for x. What do you get? If you said x minus a equals to 0 and then add a on both sides, you'll get x equals to a, right? You cancel that and get x equals to a. So you plug in that a into x of the function f. Okay, you replace x by a. Whatever number you get will be the remainder. Okay, and as always, if the remainder is 0, then x minus a will be the factor, and if x minus a is the factor, then a will be the root, meaning that to check whether a number is a root or not, what you do is you plug in that number in a, in x. Okay, and then if the remainder is 0, then you get that is a root, otherwise it is not a root. Okay, let's see some examples. Example 1, find the remainder when fx equals to x squared minus 6x plus 9 is divided by x minus 3, right? You are dividing by x minus 3, set that equals to 0 and then add 3 on both sides, you'll get x equals to 3. So to find out the remainder, what you do, you plug in that 3 for x in f. So remainder r is equals to f x replaced by 3. So what do you get? You will get 3 squared minus 6 times 3 plus 9. So how much is that? So 3 squared is 9 minus 18 plus 9. So it is basically 0. Therefore, x minus 3 is a factor because you got the remainder 0. So when you get the remainder 0, then x minus 3 is a factor. So x minus 3 is a factor. Okay, also when the remainder is 0, you can say that x equals to a, meaning that here x equals to 3 is a root of fx or 0 of fx. Okay, so basically what you do, whether if you want to test whether a number is a root or not, is you just plug in that number to the function, and if you get that is 0, basically when you plug in that is basically the remainder, right? And if you get the remainder 0, then that is a factor and that number is a root, otherwise it is not. Let's do in this example, let's find out the solution. Here f of x is, so g of x is x cubed plus 2x squared minus 5x minus 6, and you want to check whether x plus 2 is a factor or not. So meaning x plus 2, you set that equals to 0, subtract 2, you get x equals to negative 2. Basically, you want to check whether x plus 2 is a factor or not. In other words, you want to check whether x equals to negative 2 is a root or not. How do you do that? You find out the remainder. How? You don't have to do the synthetic division. Okay, what you can do is replace that x by negative 2, f or z at negative 2. Okay, z at negative 2. So what do you get? So replace all the x by negative 2, you will get negative 2 to the cubed plus 2 times negative 2 to the square minus 5 times negative 2 and then minus 6. Okay, what do you get? You get negative 2 to the cube is negative 2 times negative 2 times negative 2, that will be negative 8, and then plus 2 times negative 2 squared is positive 4 times 2 is positive 8. Okay, and then negative 5 times negative 2 will be positive 10, right, because double negative, and then minus 6. Okay, so what do you get? So negative 8 positive 8 will be 0, right, and then negative plus 10 minus 6 will be how much? That is 4, right? So the remainder is 4, meaning that x equals to negative 2 is not the root. Okay, x equals to negative 2 is not the root of this function. Okay, so x equals to negative 2 is not the root, and also x plus 2 is not the factor. Okay, so the next thing is we want to test for -1 and 3 as well. Okay, so if you plug in -1, what do you get? So to test whether -1 is a root, how do you do that? You find the remainder for x equals to -1, z at -1. What do you get? You'll get -1 to the cubed plus 2 times -1 to the squared minus 5 times -1 and then minus 6. What do you get? It is -1, and then this is plus 2, because 2 times -1 squared is +1, so 2 times 1 is 2, and then plus 5, because -5 times -1 is +5, minus 6, right? It is +7, -7, it is 0. So yes, x equals to -1 is a root. So x equals to -1 is a root, right? How about 3? You plug in 3 for x here in this function, right? What do you get? If you plug in 3, then you will get z at 3 will be 3 to the cube plus 2 times 3 to the square minus 5 times 3 minus 6. What do you get? This is 27, right? Plus 3 squared will be, basically it is always good to consider the parenthesis there. Okay, so 27, 2 times 3 squared is 9 times 2 is 18, minus 5 times 3 is 15, minus 6. Is it 0? It looks like not, because 27 plus 18 is 45, minus 15 is 30, minus 6 is 24. So x equals to 3 is not. So the answer is no, x equals to 3 is not the root. So here only x equals to -1 is the root, but -2 and 3 are not the root. How did we find that? We plugged in those numbers into the function, and then the remainder was non-zero. So if the remainder is 0, then it is the root. If the remainder is not 0, it is not the root. Okay, and to find out the factor, what we do, you solve that factor equals to 0 and then get x, plug in that value. If the remainder is 0, then that is the factor, otherwise it is not the factor. Alright guys, thank you.